You've already worked on the problem of entity recognition, but so far only used the basic approach of looking for keywords. It's much trickier to recognize entities that you haven't seen before. Say you're building a voice-controlled music speaker, and now imagine that you had to train your NLU model with every single song, artist, and album that someone might want to play. In order to generalize, we can look at how a word is spelled, whether it's capitalized, and which words occur before and after it. This is also a pattern recognition problem, and one we can use machine learning to solve. Through the spaCy library, we have access to existing models built using large amounts of training data. When you have the option, it's a great idea to use these. To identify generic entities like places, dates, organizations, and so on, we can use spaCy's built-in NER. As before, we import spaCy. Then we load the model using NLP equals spaCy.loadN. We pass our string to the NLP object to create a document. The named entities in the document are then accessible through the doc's ents attribute, which returns an iterator over the entities. The entity type is given by the ent_label attribute, and its value can be accessed through the ent.text attribute. Something we haven't discussed before is that entities in text can have different roles. For example, when we say, "Please book me a flight from Tel Aviv to Bucharest," both Tel Aviv and Bucharest are location entities. But one is an origin, and the other is, of course, a destination. One very simple approach is to match the patterns from X to Y and to Y from X, and assign roles that way. Here we've defined these two patterns separately. So if pattern 1 matches, we know the origin was given first and the destination second, and vice versa. But roles aren't always so simple, so we'll use a slightly more general approach. Dependency parsing is a topic that's too big to cover in this course, but we will show how to use a parse tree to assign roles. A parse tree is a hierarchical structure that specifies parent-child relationships between the words in a phrase and that is independent of word order. In both the phrases "a flight to Shanghai from Singapore" and "a flight from Singapore to Shanghai," the word "to" is the parent of the word Shanghai, and "from" is the parent of the word Singapore. We can refer to tokens in the spaCy document with their indices. So first we assign the tokens with index 3 and 5 to the names Shanghai and Singapore. We can then access the parents of each token through the ancestors attribute. This returns an iterator over the parents of the token in the parse tree. Similarly, in a shopping scenario, we might get a message like, "Let's see that jacket in red and some blue jeans." It's important not just to extract the colors, but also to know which items they belong to. We can assign these colors as follows. For each color, we iterate over its ancestors and check if we've encountered an item with the statement if token in items. The first parent item is then the item to which this color belongs. Now it's your turn to extract entity roles from user messages.